So guys, scientists, we're going to do, still in the school, we're going to do the science thing today. So stuff you're going to need for your experiment today, if you're doing it at home. 1, your adult. Get your adult. If you don't have an adult, you shouldn't play with fire. This is me covering my tail. I don't want to hear anybody saying, oh, I set my house on fire because you told me I set something on fire. No, have an adult present. Looking at you, Danny. Looking at you. Don't be setting stuff on fire, my dude. Okay. Anyway, so today we're going to talk about pressure. We're going to talk about what happens when stuff loses pressure and all that good stuff. So I'm going to go ahead and switch cameras. First thing you're going to do is set up your space. If you're doing your experiment at home, you're going to need that colored water in your clear or whatever plate. Not too much water. Don't get crazy on me. Just about like 1 finger width worth of water. Make sure you color it. Otherwise, it's not going to be as effective. And if you don't have food coloring, I get it. You'll still see it. It just won't be as effective. Okay? Things you're going to need. Candle. Keep it out of the water for now. Keep it here. We're gonna play with it a little bit. Yes, we're gonna play with fire. This is why you're gonna have an adult.
Can we have this little, or do it need to be bigger, like yours?
That's fine, as long as it will fit under the jar. So next thing you're gonna need is your jar or your glass. You can use like a regular glass from like your cabinet. That works too. Just mason jars are bigger, and I like them that way. So that's all you're going to need, and you're going to need, of course, something to light your fire with. I have one of these stick lighters, very safe. I like these things. So if you're going to do this, first thing I want to do is experiment with what happens when we just light something on fire and then take away its air. Okay? So first thing you're going to do, go ahead and light that candle. Now, this is not in the water. This is just laying on the table. Make sure it gets a good burn going. I know like candles, especially if they're new, they tend to take a little while to light up. Give it a second to like get itself going a little bit. Now, once that's started, I want someone to go ahead and take a guess for me. What's going to happen when I put this jar over it? What's going to happen?
Don't play with fire.
The fire's gonna stop.
Fire's going to stop. Why is the fire going to stop, Danny?
Because it needs oxygen to keep on going.
It needs oxygen to keep on going. When we take away the oxygen, it should stop. Now, it doesn't stop right away. It does take a little bit to like realize that it's running out of air because it burns up all that oxygen inside. Notice the fire's already getting smaller than it started. It's getting lower and lower and lower because it's burning up all that oxygen. And now mine is all burnt up. It's gone. So now, in this canister right here, now the oxygen has been all burned up. Mind you, it's burned up the air in there. There's no more air. There's no more oxygen, at least. In there, do you think it's low pressure, or do you think that's high pressure? Tristan says low pressure. Tristan, why do you say low pressure? Speak up.
Because like all the oxygen is gone in there.
And so now there's fewer air molecules in there, which is making it low pressure. When there's less stuff going on, that makes it less pressurized. Okay, now we're about to try this out again. This time, go ahead and place that candle in the water. I'm gonna bring us nice and close so you can see what happens for those who are doing this at home, who aren't doing this at home, pardon me. Now, go ahead and light that candle again. Again, let it get a good burn going. You want it to get really nice. Now, if you just did your mason jar thing, actually blow in it, get some more air in there, and like move it around a little bit, get some air. Move it around, move it around, move it around, move it around. You want there to be lots of air in there, okay? Now, You're going to place this on top like that. Now let's watch what happens. Now, mind you, this is creating a low pressure zone. We just talked about that. As it creates a low pressure zone, it creates what's called a vacuum. Look at that, look at that, look at that. The water is rising up inside the jar, and the water outside the jar is going down. Whoa, 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 whoa. So now, let's talk about it. Why did that happen? Why did that happen?
Because the air was rushing out while the water was coming in.
So can the air rush out, though? Did you see any bubbles leave it?
Yes.
I didn't see any bubbles leave it. So air didn't rush out. What happened to the air? What happened to it? What happened to the oxygen?
When the candle was getting rid of all the oxygen, it was almost like some sort of vacuum.
Yeah.
The water inside of it too.
Exactly, just like that. What happened was, if you can mute yourself again, because there's a lot of background noise. What happened was that fire burnt up the oxygen. This created a low pressure zone inside the jar. That creates a vacuum. If you ever used a vacuum at home, it sucks up stuff from outside. When it creates a low pressure zone, and here's the big deal for today, here's the big understanding. Matter tends to move from high pressure zones to low pressure zones. Kind of like if you're in a room that's full of people, you're like, I got to get out of here. There's too much, especially right now in COVID times, you want to leave that room. When you leave, you're going to a low pressure zone, a low density zone. You're like, oh, I feel better now. That's just like our water. The water rushed in from the outside into a lower pressure zone. Because all matter, air, water, solids, want to be in low pressure zones. That's what happened.